Hello, and welcome to Aggressive Physics. Today is day 142. What we're going to do today is review electricity and magnetism. So hopefully you've already completed your assignment, and we're going to solve the electricity and magnetism sample problems now. We'll take out the whiteboard, and we'll see how you did. Hopefully you were able to solve a number of these problems correctly. These are topics that we've covered recently in the course. Otherwise, if you had some difficulty, make sure you review those lessons. Let's take out the whiteboard now and solve electricity and magnetism problems. Thank you. All right, on to the electricity and magnetism review. Now we have current flowing through a light bulb is 2 amperes, so that's I equals 2 amps. How many coulombs of electric charge pass through the light bulb in 1 minute? So the time has to be in seconds, so it's 60 seconds. The equation is I equals Q over T. 2 amps equals Q over 60. 60 times 2, 120 coulombs. Choice 3. Now, number 2. We have 2 identical resistors in series. So if we have it in series, it's 4 ohms total. So that means they're each 2 because you add resistors in series. Now if we put them in parallel, we're going to do 1 over R equals 1 over 2 plus 1 over 2, which is 2 over 2, which is 1. And then when we flip it, we still have 1. So it's 1 ohm, choice 1. All right, number 3. Toaster connected to a 120 volt outlet, so V is 120, V for voltage. Current is 6 amps. What's the energy in 5 seconds? So E equals PT, or in this case, VIT. So we have 120. Times 6 times 5, and that's 3,600 joules of energy, which is choice 3. All right, number 4. How much work is required to move a single electron through a potential difference of 100 volts? The equation is V equals W over Q. We want to find the work, and we have 100 volts. W over Q. Electron is 1.6 to the negative 19 coulombs. So 100 times 1.6 e negative 19 is 1.6 times 10 to the negative 17. And that's going to be choice 3. All right, number 5. So we have a circuit where we have a parallel set of resistors. And we have a 10, a 15, and a 20 ohm resistor. So we're going to do 1 over R equals 1 over 10 plus 1 over 15 plus 1 over 20. So on the calculator, we're going to use the x to the negative 1 button. So it's going to be 10x to the negative 1 plus 15x to the negative 1 plus 20x to the negative 1. We're going to get an answer, but that equals 1 over R, so we have to reciprocate that as well. We have R is 4.6 ohms, and that's choice 3. All right, 6. When would the ammeter show the greatest current? And we have a number of different circuits. We have a couple of series, and then we have a couple of parallel. Now, the greatest current is going to flow when you have the smallest equivalent resistance. So the ones where are in series, that's going to add together, so it's going to be a big resistance. So those are going to be out. So now we're left with 2 parallel circuits, one with 2 and one with 3. Well, the more resistors we add, the lower the total resistance. So it's going to be the one with 3 resistors, which is choice 4. All right, number 7. We have several pieces of copper all having the same length with different diameters. what is the representation of resistance versus cross-sectional area? Well, the equations R equals PLA, and R and A are indirectly related. So that's going to show an indirect graph like that, which is choice 4. All right, number 8. What is the relationship between power and current? I'm sorry, power, which is P, not R, and current, which is I. Well, the equation, if the resistance is constant, is I squared R. So that's a direct square relationship between these two. Since R is constant, it remains the same. So what shows a direct square relationship? Well, one that has a curve. And if it's power and current, that is choice 4. All right, number 9. How much current flows through a 12 ohm flashlight? So R is 12 ohms, and the voltage is 3 volts. So current, V equals IR, 3 volts equals I times 12. 3 divided by 12, 0.25. Choice 1. All right, we have current and resistance. So constant potential difference applied across a variable resistor held at a constant temperature, which represents the relationship between resistance and the current. So resistance versus current. So if V is constant, we have I and R. So as the resistance goes up, current has to go down. So it's an indirect relationship. And that's going to be choice 1. For 11, we have charge A, which is plus 2Q, a test charge here, and minus 2Q. So you have A here, test charge, and then B, negative 2Q. In the diagram, positive test charge is located between two charged spheres. Sphere A has a charge of plus 2, and it's 0.2 meters away. The other one is 0.1 meter. If the magnitude of the force on the test charge due to sphere A is F, so we have force F between A and the test charge, so that's force F. What is the magnitude of the force due to sphere B? Well, B has the same charge, but half the distance. So, equation for force on charges is KQQ over R squared. K is constant, so I put a 1. The charges are the same, so I'm putting 1 on each of those, but the distance is half as great. So if we do 1/2 squared, that's 1/4, but since it's on the bottom, it's 4 times bigger. So it's going to be 4F, which is choice 4. Now, 12. Potential drop across a 300 watt floodlight. So power is 300 watts. Voltage is 120 volts. What's the current? All right, the equation is P equals VI. So you're going to do 300 divided by 120. And the current is 2.5 amperes, which is choice 2. All right, 13. We have a 330 ohm resistor, so R is 330 ohms. It's connected to a 5 volt, 5 for V, battery. Current flowing through the resistor is V equals IR. 5 volts equals I times 330 ohms. And we divide 5 divided by 330. I is 0.0152. All right. Now everything's in milliamps, so we got to go 1, 2, 3, 15.2 milliamps, which is choice 2. All right, 14. What's the electric force acting on an electron located in an electric field with an intensity? So the electric field intensity is 5 times 10 to the 3 newtons per coulomb. And we have an electron, so it's 1.6 times 10 to the negative 19 coulombs. The equation is going to be E equals F over Q. So I'm going to multiply E and Q, so 5E3 times 1.6 E negative 19. And the force is 8 times 10 to the negative 16 newtons, which is choice 2. All right, 15. All right, we have graph showing potential difference in current, and it looks like this. And now what we're going to do is increase the temperature. So if the temperature goes up, the resistance goes up. Now the slope of this graph shows resistance. So what we need is one that shows a steeper graph. And the only one that shows that is choice 1. No math required. 16. All right, we're looking at a junction rule. We have 3 amps into a junction. We have 4 amps into a junction. We have 6 amps out of a junction. And we have P. And we got to figure out what we have. We have 3 amps plus 4 amps equals 6 amps plus X. And I'm going to assume it's going away. So I'm going to add it to the away side. 7 minus 6 is 1 amp equals X. So it's 1 amp away, which means away, this is point W at the bottom. So it's 1 amp towards W, and that would be choice 1. All right, 17. What we have is a parallel circuit. 1, 2, 3 resistors, and we want to find the current flowing here. So what we need to do is find the equivalent resistance and do V equals IR. So equivalent resistance, 1 over 20 plus 1 over 30 plus 1 over 60. So that will be 60 is the least common denominator, so we're going to make this 3, we're going to make this 2 and 1. 3, 4, 5, 6 sixtieths equals 1 over R. So 60 over 6, which is 10 for the equivalent resistance, 10 ohms. Since the voltage is 110, we can do V equals IR. 110 divided by 10 is 11. And that's choice 4. So 11 amps, or choice 4. All right, 18. We have 4.8 times 10 to the negative 17 joules of work. 4.8 times 10 to the negative 17 joules. And it's an electron, so we know Q, 1.6 to the negative 18 coulombs. Well, the equation's V equals W over Q. And we're looking for potential difference, so we're looking for V. And that's going to be 4.8 E negative 17 divided by 1.6 E negative 19. And I wrote negative 18 here. Let me just change that, negative 19. And you get 300 volts, which is choice 2. All right, 19. What's the current through a wire if 240 coulombs, so Q is 240 coulombs, and time is 2 minutes, so it's 120 seconds. I equals Q over T. 240 divided by 120, 2 amps, which is choice 2. And now for 20. Which graph represents the relationship between the strength of an electric field and the distance from a point charge? Well, I know that E is KQ over R squared, which is a combination of the equations E equals F over Q and F equals KQQ over R squared. And when you put this here, one of the Q's cancels. So it's, for distance, it's an indirect square relationship. So as you get farther, you have an indirect relationship, so it should look something like that, and the closest one to that is choice 3. On to 21. What's the total work done to move a proton, which has a Q of 1.6 times 10 to the negative 19 coulombs, through a potential difference of 100 volts? V equals W over Q. You're going to multiply V times Q, so you're going to do 1.6 to the negative 19 times 100. 1.6 times 10 to the negative 17 joules of work, which is choice 2. All right, 22. Two charges 2 meters apart repel each other with a force of 2 times 10 to the negative 5 newtons. If the distance is decreased to 1 meter, the force of the repulsion will be. So in this case, we have KQQ over R squared. Everything stays constant on the top, and I'm going to half my distance. But if I square that half, I get 1/4, and since it's on the bottom, it's 4 times bigger. So I started with 2 times 10 to the negative 5 newtons. What I need to do is multiply that by 4. 4 times 2 is 8. So it's 8 times 10 to the negative 5, which is choice 3. On to 23. What we're looking at here is a potential difference. V is 1.5 volts and current is 0.2 amps. Time is 60 seconds. We want to find the energy. Energy is PT, or in this case, VIT, because we don't have power yet. So let's multiply the 3 together. We have 1.5 volts times 0.2 times 60. And the energy is 18 joules. And that's choice 4. All right, now we're on to 24. Potential difference applied to a circuit remains constant as the resistance is varied. So V is constant, V remains the same, R varies. Okay. Which graph best represents the relationship between the power and resistance of this element? So if V stays the same, so we have P equals V squared over R. So if V is constant, as the resistance goes up, the power goes down. So that's an indirect relationship. So that's going to be a curve like this. Power, resistance, and that's going to be choice 2. All right, 25. We have an oil drop experiment, and we're looking for what the charge of the oil drop could be. Now we know that we have excess number of electrons on it because it's negatively charged, so it's a bunch of electrons extra, and every electron has 1.6 times 10 to the negative 19 coulombs. The equation we use is Q equals NE, and N has to be an integer. So if we just divided each of these by 1.6 to the negative 19, we'll figure out which one is possible. So the first one is actually our answer, and you have 4 extra electrons. But then if we try the other ones, we're getting a half number for 2. We get 1 to the negative 19, which is not an integer for that one. And then 3.2 to the negative 50, you're also going to get an integer. So the only one that we could have is choice 1. 26. All right, heating element dissipates a power of 400 watts, 4 times 10 to the 2, and the voltage is 120 volts. What's the resistance? So P, V squared over R, 400 equals 120 squared over R. So 120 squared divided by 400, I get 36 ohms. And 36 ohms is choice 4. All right, 27. Electron moves at a speed of 3 times 10 to the 7 meters, perpendicularly to a magnetic field that has a flux density of 2 teslas. So B is 2 Tesla. What's the magnitude of the force on the electron? Well, force is QVB. But we need to know Q. But an electron, it's 1.6 times 10 to the negative 19 coulombs. 1.6. So we just multiply the 3. 1.6 e negative 19 times 2 times 3 e7. And we have a force of 9.6 times 10 to the negative 12 newtons, which is choice 3. All right, now 28. Two identical spheres, insulated stands, are given a charge of 2 times 10 to the negative 6 coulombs. And the distance, so Q, D, 2 times 10 to the negative 1 meters. So we have electrostatic force, which is KQQ over R squared, and we know Newton's third law, they're equal. So all we have to do is find the force on one, and we'll find the force on both. So now it's 9E9 times 2E negative 6 times 2E negative 6. And then we divide that by 2E negative 1 squared. And we have a force of 0.9 newtons, which is choice 2. All right, 29. We have a parallel circuit where both switches are closed. So we have a 4 and a 12 ohm resistor connected in parallel, and they want to know the equivalent resistance. So 1 over R, 1 over 4, plus 1 over 12. So that's 3 twelfths plus 1 is 4 twelfths. So that's 4 twelfths equals 1 over R. So R is 12 fourths, which is 3 ohms. Choice 3. All right, 30. We have a parallel plate in a circuit, and it's asking us to find the electric field intensity. Well, anytime we have that, the equation is going to be VED. We have the distance between the plates, which is D. We have a speed, which is 2 times 10 to the 6. The problem is this is V for voltage. Lowercase v is for speed. And in the diagram, it says it's a 500 volt power supply. E, and the distance is 2.5 times 10 to the negative 2 meters. So we're going to divide 500 divided by 2.5 e negative 2. And I'm going to get 20,000 newtons per coulomb. Now, of course, that's going to be in scientific notation, 1, 2, 3, 4. So 2E4, or choice 2. All right, 31. We have a diagram showing a series circuit. And the series circuit is a 10 and 20 ohm resistor. And it's a 120 volt source. So if we find the equivalent resistance, it's going to be V equals IR, 120 volts, I in 30 ohms. 120 divided by 30 is 4 amperes, which is choice 4. All right, for 32, we want to find the smallest equivalent resistance. Now, if we look at the first one, 2 plus 2 is 4 ohms. The fourth one, 1 plus 1 is 2 ohms. Those are series. The second one, 1 over 2 plus 1 over 2 is 2 over 2. And then when we reciprocate that, we get 1 ohm. And the third one is 1 over 1 plus 1 over 1, which is 2 over 1. And when we reciprocate that, we get 1/2. So we have 4, 2, 1, and 1/2. So the answer is going to be 3. And it's usually a parallel circuit because they get smaller as you have more paths for current to flow. All right, 33. When does this graph show Ohm's law? We know that Ohm's law is V equals IR, and that means we have a direct relationship. So where is it straight? And that's BC, which is choice 2. All right, on to 34. We have 3 resistors in parallel, and they're all 3. 3, 3, 3. So we're trying to find the total resistance. So it's 1/3 plus 1/3 plus 1/3, which is 1 over 1, is 1 over R. And when we find the reciprocal, what we do, so it's 1 over R, it's 1. And 1 ohm is choice 1. And on to 35. We have a table below shows the length and cross-sectional area of 4 pieces of copper at the same temperature. What is the highest resistance? So R equal plah. Now, since the row is all the same and they're all the same temperature, we're looking at L versus A. So what I'm going to do is divide each of these, and I'm going to figure out which one has the highest value. So let's look at A, B, C, and D. For A, I'm going to do 10 divided by 2e negative 6. I'm going to get 5e, 1, 2, 3, 4, 5, 6. I'm going to do 10 divided by 1e negative 6. I'm going to get 10e, 1, 2, 3, 4, 5, 6. I'm going to do 1 divided by 2e negative 6. I'm going to get 5e, 1, 2, 3, 4, 5. And then I'm going to do 1 divided by 1e negative 6. I'm going to get 10e, 1, 2, 3, 4, 5. So the highest one is going to be, B, which is 10 times 10 to the 6. So 10 million ohms, choice 2. And that concludes our electricity and magnetism review.